While solving this problem, we will be using series resistance calculation formula. Generalized formula for the calculation of equivalent series resistance of any circuit is given here. RT is the total resistance of series network from R1, R2, R3 to Rn is the number of resistances that are connected in series in that network. Total resistance of a series network is always equal to the summation of all individual resistances connected in that series network. We also will be using parallel equivalent resistance calculation formula. This particular formula is for two resistances connected in parallel. In this scenario, we will be having a parallel connection that includes two resistances only. That's why we have taken this formula. In coming video, we will solve more than two resistances in parallel, so I will introduce you with a generalized formula. So let's proceed towards the problem. Learning assessment E2.14. Calculate the total resistance of the circuit in given below figure between point A and B. This is the circuit diagram of given problem, and we have to calculate the accumulative or equivalent resistance between these 2 points A and B. So without wasting time, let's proceed towards the solution. We will start solving this problem from this end. If we observe, these two resistances are connected in series. So first we have to calculate their equivalent resistance. While calculating equivalent series resistance, we simply have to add all the resistances connected in series. In this case, these two resistances are connected in series, so their sum will be equal to their equivalent resistance. That is 3 plus 6k, it will be equal to 9k. Now we can replace these two resistances with a single resistance which will be having the value of 9 kilo ohm. Here is the updated diagram. If we observe in this circuit, these resistances are connected in parallel and these are total two number of resistances. So for the calculation of these two resistances equivalent resistance, we will use equivalent calculation formula for two parallel resistances. We will assume this is the R1 and this is R2. So calculate their equivalent resistance by entering the values of R1 and R2 into the equation. Solve this equation to calculate the R equivalent of these two resistances, that is 6 kilo ohm. These two resistances can be replaced with a single resistance that have the value of 6 kilo ohm. So rearrange the circuit. Now if we observe, the circuit is converted into a simple series circuit. So we can calculate the value RAB. Value of RAB will be the sum of all these three resistances. That will be 6 kilo ohm plus 6 kilo ohm and plus 10 kilo ohm. Add these resistances together to calculate the value of RAB, that is 22 kilo ohm. So this was learning assessment E2.14. Thank you. See you again in next video.